Thank you everyone for being here for the very first run of the Troubleshooting containerized applications. I'm counting on you for feedback after this presentation, and of course for more problems to be shared and things to be troubleshooted, of course. Well, let me introduce myself. We've met this morning. I am in the program committee at Vox Days Cluj-Napoca and Vox Days in Romania, but I'm also working for IBM, mainly on projects involving Java frameworks, IBM Cloud, sometimes Kubernetes, and yeah, this is why the topic today. I'm also the co-founder of Bucharest Software Craftsmanship Community, where I occasionally share from my experiences together with my colleague Victor Rentea. He's more present in the community than I am, to be honest. But I'm also there in the background, running the scheduling for the events and, advising and keeping this community going. So for those of you that do not know, Bucharest Software Craftsmanship Community is about us, Romanians. We only speak in Romanian at this community. And for those of you that have not joined it, you're welcome to join it. Most of our activities are online. However, we're going to have our first on-site event on 21st of November with two colleagues from IBM in Bucharest. So that's going to be our first on-site event, and we hope to have many more on-site events even here in Cluj. Why is this topic today? So the topic of today is because, well, we're kind of working on these modern architectures, and we saw in the morning about reactive architectures. We saw about Quarkus. Everything's modernizing around us. All of us want to work with microservices, right? So this is the new goal for all of us. We want to work on microservices-based projects. And inevitably, we run into containers and running things in containers, or actually Kubernetes. And to be honest, Kubernetes is for many of us as developers kind of magic. And also the new practices that we are kind of getting acquainted are considered magic. But we are developers, we're engineers, and we rely on facts. Our main goal all the time is to have an application up and running while having a great time developing it. So I think this is the base of our jobs. You want to go to work happy, and you want for things to be up and running. And before diving into some heavy stuff, I'm going to talk a little about the magic behind the pod. So all your nice applications, Java applications, are running basically inside a pod. And a pod is a deployment unit in Kubernetes, has the life cycle of the Linux process, and it goes through several phases. I think you've seen earlier one of the phases of the pod for Burr. Some of his pods were in the pending state. So, what pending state pod means that Kubernetes is accepting that pod, but the containers are not yet created. There are a few reasons why the containers are not yet created. If you have a large image, then it's going to take a while for all that image to be downloaded and to be started. Also, if you are having a long-running process when you're starting your application, again, you're going to see pending for more time over there. Then we have running. This is the best one of the phases that we want to achieve. So we want our application to be always running. Means that all the containers in the pod are created, or at least one pod is created if your deployment has multiple pods. Of course, there's also succeeded. This means that, well, your application is done with what it did, but it has done the right things, and it ended up successfully what it was doing. Most of the time, the pods that are in the succeeded phase, you see them with jobs and cron jobs with Kubernetes. Also, you can have the failed state. This is not very nice. When you see a pod in the failed state, it means that, well, something went wrong, it terminated with an error, it's not great. So this is what we don't want. And unknown is when it cannot be determined what is the phase of your pod. So it's none of the four, so the state is unknown. Also, what we're going to use in the demos today is a bit about the relationship between deployment, replica, set, and pod. And the thing is that every time you're applying a definition of a deployment object, what you're doing, you are instantiating a deployment resource that's going to have a selector, a template, and a number of replicas to be specified. Based on that deployment resource, there's going to be created a replica set with a number of replicas also, and also a template. The selector is going to be the same to have consistency. And also, we're going to have a number of pods based on the number of replicas that we specify over there. So it's like a chaining of events when we are applying one of those YAMLs. Those being said, let's dive into the first problem. It's like, what if my pod is not feeling well? But before going into that, let me show you a little bit. Okay. One moment. Of what we're going to have today in this setup. Let me get this bigger. Okay. So, trying to make this. I'm not going to enter in presenter mode. So what I have is this basic Spring Boot application. I think many of you are working with Spring Boot in terms of in microservices, because it was the kind of the first choice when we started working with microservices, and we embraced it. However, nowadays we have many more options like microprofile, and of course, do not so Java-based microservices if you're not a fan of Java. So we have a basic Spring Boot application, my Hello World customized example, with a very simple Hello World controller, getting a variable from the environment, so nothing special around it so far. The only thing that I have over custom, let's say, is my health indicator. I'm using Spring Boot 2, so I'm using the reactive health indicator. And I've done this configuration, seems pretty simple, it's pretty okay, everything should be fine. However, this kind of application can go into not feeling well state. Okay. If some stuff are not taken into account. So, for example, let's talk about health checking. So you saw my health indicator over there. Now, the good thing about health indicators is that they're telling you a few things about the status of your application. So there are two very well-known health indicators. The readiness probe, and that's one showing when the container is available for accepting traffic. So you don't want to send data, or you want to access an application that's not able to respond to you. So this is why it's good to set up this probe. And there's also the liveness probe that's telling you that probably you should restart your container because it's not feeling that well. The good thing about these two probes is that they can be run throughout the entire life cycle of the process, so it's not like one-time thing. The liveness probe is going to check how well is filling your application, depending on how you set it up. However, there are some things to be known. So there are a few parameters that you're playing around with the readiness and the liveness probe. But if you're not playing quite well with them, you might end up with problems. So one of the things seen with the readiness probe, because you want to check the readiness of your application, is that, well, when you have a dependency to, let's say, you're caching something before you're starting your application, so you want to cache something before you start your application, that takes a little bit of time. Well, if you're not setting up the readiness probe quite well, you might end up having the readiness probe in the give up state. So what happens with the readiness probe that gives up, it means that no traffic is routed to the pod, so you cannot access your application. Another thing that has been seen with readiness probes and dependencies is like when your microservice is consuming a third-party service, and it's not in your concern, so it's given by somebody else. And that is having some latency in responding with that, but you are making sure that you're checking your readiness using that endpoint. What it happens is that, well, you will end up with no traffic routed to the pod if you're not playing well enough with the parameters. And of course, the liveness probe, when it gives up, it will restart your pod. The thing with the liveness probe is that if something is wrong on the endpoint that you are checking your health, I mean, like you're really trying to see your application is healthy and is connecting to, I don't know, it's accessing a database and something went wrong with that path, with that access, what it will do, it will all the time indicate that the pod needs to be restarted. So you'll end up seeing a lot of pods being created and over again. However, these are very good. Now, As mentioned earlier, what if there is a small temporary increase in latency to one of the dependent service that you are actually accessing to check your readiness probe? So this is the case that we're going to take into account today. I've deliberately made my first, let me check, it's the configuration. Yeah. I've created a role that I want to be, well, a deployment manager. So I created this role here. Let me just make it a little bit bigger. That is applicable only for namespace dev. I have access only to certain API groups, and I can see only the deployment resources. And of course, the verbs that I can use is get and list. So I'm very, very limited in what I can do. Next, I want to create a user for that. So I created a user for myself. And I've used a binding as specified earlier. So I'm the user Anna, and specifying the API group. And of course, the reference for the role is the one that I showed you earlier, the deployment manager. When the deployment happens, that one is using a service account. However, I should be able to get and list that deployment. And you can see here that is using the Hello World service account when it's deployed. But I can also have interaction with this deployment. So I'm going to apply this one. Okay. Okay. And then I want to verify if Anna has some access. Can I, well, get deployment as Anna in the namespace dev. So this is how you can check that you can get deployment objects without being authenticated as Anna. So right now I am an administrator, and I can just see if Anna has access to that when I'm going to authenticate with my Anna credentials. So I can get deployments. Now, if I want to see that I can create deployments as Anna based on the limitations of the role, and the answer is no. So I can do that. I can just get, and just now trying to also list, because I could get and list the deployments. So that works. But these are my only actions that I can do in the namespace dev. And of course, I don't have access to the other namespaces, which is not that nice. But how you can validate is this one, like you use the kubectl authcan and see if that is working. So with user impersonation. Then how you can change that role and modify what happened over there. Firstly, you have to have enabled the audit. So you check the audit logs. And then you grant the proper role across the role. So this is how I got upgraded in my role, and I could be able to do more things by my colleague who had admin rights on that namespace. So this is how you're troubleshooting. You're just creating, again, the credentials, the permissions as you intended to be for that user. You're not limiting it with initial stuff. But first, you check the audit logs because you want to make sure that that user is indeed limited, and of course. And also with the role binding and everything. Now, this one is quite big. The pod is running, but not as expected. So the situation is like pod is running, but it's not running my version, the one that I expected over there to be running. So what happened? Or is running, but actually I cannot access anything from inside that application. So what's going on over there? Now, how to validate what's running inside of a pod? Well, what Burr, I think, would do when he had that pending state over there was to actually get the definition of what he had deployed to check it if it was okay, firstly. So this is one way, like exporting the definition of your deployment that you're having for that pod and put it somewhere on the disk and then inspect it. Now, you can validate that locally. So typically, validation is out of the box when you're deploying on Kubernetes. However, some people like to use this thing over here because you can edit. And well, if you're in a hurry, you have access to the edit of resource something. People are like sometimes doing these things, and it works, right? And then it doesn't work as expected anymore, and you get issues. So validation is good when you're getting the definition from what you have deployed and validate again locally. Also, when you are exporting the information from your running pod in order to run it locally, is way, way better to debug and see what's going on over there. What if you want to see what is inside a pod? So one way to see what is inside a pod and what's happening over there is by using the kubectl exec command. So one way to do that is get pods in the namespace dev. And the exec instruction can actually introduce a shell for you to debug and see what's in the pod. So for example, let's go into this one and say kubectl exec -it. Okay. Minus namespace dev minus bin bash. Okay. What did I do wrong? Should have worked. Wait a second. I have my help in hand here. It's weird. Okay, yeah, sorry. Thank you very much. Thanks. So now I'm in the pod. I can look into it. I'm logged in with the user that I've defined for my image to have access to the insides of my pod. I can write different commands and see what's actually inside over there. I can navigate through the entire, through all the directories and see what's in those. So it's much easier to look at what is actually running. And of course, when I'm done, I can say exit. So this is one way that, like mounting a bash and just running it, and it's all like if you're running on local. Or you can just go into the dashboard and you can go into exec, and it's the same thing. So now there's a question about replacing images. So how can you replace images when you're already running an application? So one way of replacing images is, well, if the image tag has changed, but your deployment has the old tag, well, for that one way of doing it is by setting the image to the new tag, and of course record that change on your deployment so that you can be able to roll back if something is not working as expected. And this is how you can like just swiftly replace it and have it all up and running. Another way of doing that, this is mostly for the images that have not changed, is to use the rollout restart deployment. So typically, you just want to trigger, again, the deployment in order to see that the image has changed for you. And thirdly, well, if the image tag has not changed, there's another option to add your own label and patch the deployment. So this is more like a hack. It's not necessarily something that's recommended, but it works. So one way of dealing with this, one sec, where did I had mine? Here, images. I never write patches. I'm always writing them first, and then I'm copy-pasting them because of the escape part. So let me do this. So what I'm going to do, I'm going to patch the deployment with my own label in order to make sure that it gets the new image. This means that the deployment will be triggered, it will recreate the pods, and will pull the new image. Reason being for these hacks and not for others is that because we're not using all the time the pull policy set to always. So another way to make sure that you're running the latest image is to have, one moment, here, the image pull policy set to always instead of if not present or never. But the always pull policy is not very recommended, so it's most of the time you're running with if not present and never. There's also a hack, like you modify the pull policy per need if you really want to invoke it and you set it to always. However, it's not recommended to do that. It's much easier to set the image tag or to just roll out restart or just do a patch. So these are much more simpler ways of dealing with those things. Last but not least is about working with volumes. So working with volumes, there's something in the documentation that a lot of people do not look into. So this phrase kind of marked my last month with the fact that the volumes cannot mount onto other volumes or have hard links to other volumes. So there was a situation where we kind of did a hard link to another volume, and we were not kind of seeing why it's not working as expected until we found this line. So one way of that is that the mounting operation can only mount existing volumes in paths. So this is one thing to be known. But I've created for you a small demo for this one. I really tried to remake what we had, but it didn't work as expected. So, for example, I had two volumes. One is called backup volume. Okay, the backup volume with the persistence volume claim having the host path set to home project backup, and the upload volume having the path set to home project's upload. So these two volumes can be mounted into the cluster. They have their own persistency volume claim. It's fine, they're working, they're running. And, well, one of our colleagues saw that this is over there. It's home projects. It's very common also for the backup. It was home projects. And thought of doing, actually, this one. Yeah. So thought of, like, why not mounting here and say directly this root, and then execute the command, because you see everything if you just put the base, right? Because they had the same base. They could have worked as it happens. So what it did happen is that, let me just show you on this one, just making sure that we're running the right claim. Upload data. Just kubectl at pvc. Okay, so it's running the right one. Okay, apply -f, sorry. Actual job minus namespace dev. So the actual job was created. Okay, jobs, dev. So my job, oh, I don't have internet. Hope for me it's gonna work. Forgot about this one. Let me try deleting it. Creating it. Okay. So it's green, creates a pod. The pod is running. Everything's fine, except for this one. When it tries to execute the command, it cannot open that because of the root of what I said when I'm mounting my volume. So always pay attention to the specific path where you're mounting your volume. You cannot, even though that you're seeing common paths, do not mount into the root one. You won't have access to that one. Another thing to be taken into account when it comes to volumes is the default storage class. So one thing that I noticed is that, well, the default storage class kind of varies between providers and even, well, when you're running locally. So the default storage class is not always the same. And I had the situation when I was creating a volume and my local was running perfectly fine. However, when I mounted it into the cloud, because I didn't look with what is the default storage class, it happened that it didn't work as expected, and I had the PVC always on pending, and it was because of the storage class. So always check on that one. Another thing to be taken into account is that not all the types of volumes and all the storage classes are creating some default directory. So again, take a look into the path and what is over there. So sometimes you might need to create by hand the directory that you are trying to reference. Last but not least, I'd like to draw your attention to something related to when you're troubleshooting stuff and when you're having things that that seem like cannot be done, or it's a lot of pressure, to worry to fix the problem instead of blaming others on who is to be blamed for that issue over there. And since I think I have more 15 minutes, I will tell you a second story because I didn't want to bring this unless I had time. Where you're referencing for charts or for other things that are considered to be stable, that they might not be as expected, working as expected. And the troubleshooting on that one was like, okay, I used the other version, I looked at the commits in the repository for the Helm, and I used the one that I had before in order to make the deployment as expected. There was funny that when I Googled the error that was thrown, it was telling me to do total different things and to overwrite some stuff that were way too complicated just because somebody made an accidental commit on the stable part. So those being said, sometimes the most difficult problem has the simplest solution. So let's worry about fixing that and not very much into the problem. So those being said, I want to thank you for your attention. I'm open for questions, by the way, because I'm sure that I haven't addressed everything that you wanted, and I want feedback. So please ask me questions. Yes? What? I'll share it. Also the code, by the way. I didn't want to run much of the code, but all the situations depicted have associated code. So I'll share both the presentation and the code, no worries. I'll share it on Twitter, if you have Twitter, and Andra will take care, Andra and Alex from Workspace will take care to share it, no worries. Yes? I was using stable, so when you're using stable and you're referencing things that are stable, you're kind of using the latest. So, and the reason how I realized that was the latest thing, I actually went to the repository because it was puzzling me, like it would have worked one day before, so what earlier it was working, And I looked in there and saw, well, there was a merged VR that, well, didn't have the right effect. But in that moment when I was seeing that the deployment was not working and I was thinking, I have to show this, it was looking much better if I'm doing this live. It was like, oh my God. And Google, and what you find on Google when you're Googling for your problems, sometimes is scary. I mean, the solution that the people were proposing for that was, I don't know, preposterous. I know that we love Stack Overflow and all these. I personally love them too, but not everything that's written over there works. Any other questions? Okay, you can find me over here and ask me more. Thanks.